You're listening to Don't Waste Water.
There's a lot of lithium in the world. There's a lot of capital that wants to be spent on lithium in the world, but there are not a lot of companies that can genuinely build and deliver full-scale plants, both at a DLE and at a CRC stage.
Hello, bonjour, and welcome to the Don't Waste Water podcast.
We're not going necessarily faster than the mines or the permitting process, but it does take us 12 months from a purchase order to build plants like what's behind us right now. So that's about 12 months. And if somebody wants to pilot and do a fulsome pilot, you can get that done in 3 to 6 months. So that's where you can get to the 18 months. But to your very good point, there's a whole pile of other work that needs to be done by others. There's the permitting, there's the brine disposal wells, the building needs to be put in, the equipment needs to be put into the building, it needs to be commissioned and what have you. So realistically, from a go that a company has a permit and they have financing and they point to dirt, they're probably looking at 3 to 4 years anyways, even inclusive of our timelines.
I'm your host, Antoine Valter, and in today's episode, I'm delighted to welcome back Ben Sparrow as my guest.
A lot of people talk about how evaporation ponds take 18 months to get to production. And that's just because of water having to evaporate and concentrate. How long do you think it takes to build a DLE plant? It takes 18 months to 2 years anyways. So I don't really see DLE as a faster way to lithium production than evaporation ponds.
Ben is the CEO and co-founder of Saltworks Technologies.
I think the industry is soon going to find that one of their constraints is process equipment supply.
What do you mean by that?
There's not a lot of companies producing the process equipment to direct lithium extract the lithium and then to concentrate and refine and convert it. They're going to find longer lead times.
So you're saying that basically you might be the bottleneck?
Correct. Us and our competitors. And that has implications on the water treatment industry as well, because with the lithium industry heating up and these clients move fast and they have a willingness to pay, that's going to draw capacity out of the water treatment industry. This will all unravel in the coming years. I hope I'm wrong, but I think, in fact, we already know that lead times are increasing across the board. Some of our competitors are quoting up to 3 years.
Saltworks is pioneering the future of water and lithium on a mission to provide industry-leading technologies for the toughest wastewaters, brines, and lithium refining endeavors. The most real listeners will have a déjà vu sensation when listening to this introduction. It's almost the same on my end than the one you heard last year when Ben was on this podcast for the first time. But there's one word more: lithium. Sure, Saltworks was already into lithium when we first spoke in 2022. But as Ben will explain in a minute,
it's an acceleration.
In fact, that acceleration is happening on quite a broad scale in the water industry. And it's driven by a simple imbalance. By 2030, the world will need at least 2 million tons of lithium a year. That's the most conservative estimate, and up to 3 or even 5 million tons depending on the projections. Today, it only produces 500,000 tons, which means the output needs to be multiplied by 4 to 10 so that offer meets demand. All great, right? But what does that have to do with the water sector? Well, let's cut the problem into 2 parts. First, lithium extraction or mining, and then lithium refining. When lithium mining is done from hard rock, it's not much of a water topic, but lithium can also be obtained by evaporating lithium-rich brines, mostly found in South America and a bit in China and the US. And that is an obvious water-rich application. Then there's also a new cool kid in town: Direct Lithium Extraction. There, you spot some lithium even in low concentrations in water, and you use a treasure of water treatment processes to isolate it and extract it. The second half of the challenge: lithium refining. Because it's great to extract lithium, but you want it to be battery grade to be useful. And there, depending on your source, if it's hard rock or brine, the processes will be slightly different, but they will all feature some shades of water technologies. Think of membranes, ion exchangers, crystallizers, and much more. I know that's a lot of information, and trust me, a fascinating deep dive into a fast-rising multi-billion-dollar application with an obvious impact and ESG compound, given its importance in the EV revolution. So here's my proposal. Embark with me on that journey, and I'll take you to places on the edge of the water landscape. Today is chapter 1 with Ben Sparrow. We discuss concentrating, refining, and converting lithium, direct lithium extraction, but also a surprise little project of mine towards the end of the episode. And of course, as you would expect with an awesome guest like Ben, much more. Over the next weeks, I'll take you to the leading direct lithium extraction players such as Standard Lithium, Helios-X, Vulcan, or Energy X, We'll get to hear wise minds overlooking that sector, but also refining actors such as Veolia HBD or Aquatech, and technology pure plays such as Evolve, and a surprise closing guest for this special season. And as a red thread in the back, you'll get some updates about my secret little project. I'll tell you the full story in a recap of the season as a closing YouTube video. And as a teaser, I can tell you that I maybe outsmarted Elon Musk, that I may become very rich while having a positive impact. Is that the reason why I'm in Edinburgh today? Who knows? And did Air France lose my bags again? Who knows? But the journey starts today with Ben, and if you want to make sure you don't miss any stops on that road, hit the subscribe button and I got you covered. The journey took me basically all the way across the globe, and you can help me mitigate my carbon footprint for that by sharing this episode with a friend, a colleague, your boss, your strategy department, or whoever you think shall listen to this, and I'll see you on the other side.
This podcast is brought to you by GF Piping Systems.
Hi, Ben. Welcome back to the show.
Thank you for having me, Antoine. Very pleased to be here.
We discussed less than 1 year ago, and it feels to me like many things have changed, and the thing that maybe changed the most is me, because when we discussed together, I discovered the words of DLE, CRC, and lithium extraction. And since then, I had the chance to dive a bit deeper, and it sounded to me like I had the best person on that microphone, and I didn't leverage it right. So that's the reason why I wanted to have you back on that microphone. So thanks a lot for taking the time. So that's the very wordy introduction. There's one thing I noticed on your website between our two conversations is that last time lithium had some space on your website and was one of the topics you were addressing. Now it is really the headline, like you open the Saltworks website and it really opens with your new lithium refining testing center, your capabilities, everything you do to support that industry. So is that kind of a marketing soft pivot?
It's an acceleration of where the market is going. With Saltworks having started with industrial desalination, concentrating, refining, and crystallizing hard to treat industrial waters, those technologies translate very well over to lithium refining, to concentrate, refine, and convert lithium resources. And there's examples of these kind of machines behind both of us.
Just tell me, what's that machine and what's this one so that we have an idea?
Sure. This is a lithium carbonate reactor.
Okay.
So you put clean lithium chloride in and battery grade lithium carbonate comes out. There's some washing and drying that needs to be done. And what's behind you is a lithium hydroxide crystallizer. The two primary lithium chemicals that go into batteries are lithium carbonate or lithium hydroxide.
I've seen you recommending to go to lithium carbonate because that's the most cost competitive today, or the best way to get money out of the system today. So is that the main driver of your systems, or do you resell both of them?
Sure, and there's a fair bit to unpack there. Today, based on economics, lithium carbonate is more profitable for the lithium asset owner. And here's why. It's lower costs for them to reach the battery grade goal, and they get paid a decent price in the market. The incremental value or market price for lithium hydroxide is not as high as to sustain to provide the profits for lithium hydroxide. So ultimately, lithium carbonate is more profitable. But there's another component to it. If somebody builds a lithium carbonate plant, they can always bolt a lithium hydroxide plant onto the back end. So by going the carbonate route, you're future-proof to go with hydroxide. In addition, some EV and automotive manufacturers are installing lithium carbonate to hydroxide conversions at their battery plants in preparation to absorb lithium carbonate from the marketplace. So we help clients go in both directions. It depends. Do you want to climb a hill, lithium carbonate, or do you want to climb a mountain, lithium hydroxide?
That one, you said the input is lithium chloride. So that's what you get when you're evaporating brines. So does that mean that it is catered to this South American market so far?
It could. You could use it, but it's really catered to direct lithium extraction processes. And now, in all honesty, this is a brine refine machine. So brine refine does various things. We have brine refine machines at semiconductor plants that help remove fluoride from wastewater. We have them on reverse osmosis brines to help remove silica and scaling ions, but they also can and do precipitate out and produce lithium carbonate. So it's a flexible Swiss Army knife of a chemical reactor that you can use to do various things, lithium carbonate production being one of them.
So you explained last time how you are really focusing on the CRC, so concentrate, refine,
convert.
And you're bolting that to DLE. DLE so far doesn't have a commercial scale plant. So you are working with these junior companies or new entrants in the market. Why don't you want to go also over that hill and go into DLE?
Oh, there's a lot of great companies out there already practicing DLE. and it's a very active space. There's a lot of sorting out that will be done over the next 5 years, shall we say. Some will thrive and survive, others will fall by the wayside. We're purposely DLE agnostic, such that our clients have open access to the CRC technology, regardless of what DLE is upstream. Try to maintain commercial flexibility for our clients.
And so this refining step, would it work as well for concentrated spodumene, or is it then a totally different route?
It's a totally different route. For your listeners and viewers that are of interest, there's really 3 ways to battery grade chemicals. One is spodumene or rocks. And often the pathway is lithium hydroxide. The machine that's behind you is a lithium hydroxide crystallizer. You could use that in a spodumene process. The other way is the evaporation ponds in South America, which they concentrate naturally using the sun and the atmospheric dry air. And then ultimately they could pop their concentrated lithium chloride into a brine refined lithium carbonate reactor, but they already have methods of doing it. Or the method that you mentioned, which is DLE, where you're extracting lithium from geological brines in wet climates where you can't build evaporation ponds.
You mentioned 3 routes. There's potentially a 4th one, which is recycling lithium from battery plants or any type of lithium, the end of life of a battery or whatever. Is that something you're looking into as well?
I'm really glad you mentioned that, because 30% of the lithium that goes into a battery plant can end up being wasted. And the answer is yes. Not only are we looking into it, but 2 machines very similar to the one that's behind you are currently being started up at a lithium battery recycling plant in the US.
Let me give you a bit of behind the scenes here. I started this lithium investigation and I thought I want to have really the full spectrum. So I went to Australia, looked at the mines, discussed with DLE companies, I discussed with evaporation ponds companies, I discussed with battery companies, I discussed with consultants in that market. And I thought, okay, I already had Saltworks on that microphone. Maybe there's someone else which can be active on the CRC. And I might be stupid, that's a good possibility, but I didn't find anybody else than you in that exact spot of CRC. So what's your special sauce? What makes you so unique that you are the one be all?
We absolutely do have competitors. There's a certain very large and reputable company out of France.
Okay, so the Reds.
Yes, yeah, and they equally like us practice industrial desalination, and with that, they're a leader in CRC and lithium. So what's our special sauce? What sets Saltworks aside? Our plants are highly modularized and highly digitized, and what we're finding is that translates into higher lithium yield and recovery. That's very important, and equally shorter timelines to get a plant up and running at site. So rather than stick building a lithium refinery at a remote site that can be quite expensive and then having to commission it at a remote site, all of our plants are modular built here in this factory and pre-commissioned and pre-tested here. They're Lego blocks, adult Lego blocks that go to site and can be placed down and then bolted together. They're also pre-commissioned here and highly digitized. So we use advanced levels of automation to reduce labor needs and also to reduce chemical consumption, increase precision, and increase yield.
You were kind enough to give me some pre-reading before that conversation, and something really struck me in what you sent me, which is that your timelines are incredibly short. You are advising people to go for a first test, then a pilot, then a demo plant, and altogether it takes 1 year, 1.5 years. And when I look at the DLE projects out there, or even the evaporation ponds projects out there, the ones which want to go a bit beyond the existing 4 ones, they all have 10 to 15 years timeline. So what makes you so confident that you can be going so much faster?
To unpack that question, we're not going necessarily faster than the mines or the permitting process, but it does take us 12 months from a purchase order to build plants like what's behind us right now. So that's about 12 months. And if somebody wants to pilot and do a fulsome pilot, you can get that done in 3 to 6 months. So that's where you can get to the 18 months. But to your very good point, there's a whole pile of other work that needs to be done by others. There's the permitting, there's the brine disposal wells, the building needs to be put in, the equipment needs to be put into the building, it needs to be commissioned, and what have you. So realistically, from a go that a company has a permit and they have financing and they point to dirt, they're probably looking at 3 to 4 years anyways, even inclusive of our timelines. If they're going DLE, they have to figure out their DLE system, procure, install, and commission their DLE system. Which, just to switch topics to evaporation ponds for a second, a lot of people talk about how evaporation ponds take 18 months to get to production. And that's just because of water having to evaporate and concentrate. How long do you think it takes to build a DLE plant? It takes 18 months to 2 years anyways. So I don't really see DLE as a faster way to lithium production than evaporation ponds.
I have to say, I have to give credit to Joe Lowry, the host of the Global Lithium podcast, who told me that you have this element of DLE being faster because the second it starts, it's producing straight away or almost straight away. But once an evaporation pond is started anyways, it's going to produce the same yield. It's just that it has this startup phase, but which is the same than building the DLE. So in fact, that's maybe not the best argument in favor of DLE.
You're right. And so is Joe.
Nevertheless, when you look at South America right now, to stay on evaporation ponds, what I got is that they could be producing much more lithium if they had more water and a better extraction efficiency than what they have today, which sounds like something calling for a better technology to maybe reuse that water, loop the water, and maybe having a higher extraction yield, which again sounds like something where you could be helping. Am I fully off with that?
No. The key is the extraction yield. There's, if I'm allowed to say misinformation, there's some misinformation about water utilization in evaporation ponds. Just to focus on that for a second, one needs to think about the quality of water. So they're pumping up hypersaline water from underground that cannot be used for agriculture or human consumption, and it happens to contain lithium. So it's low quality water, very similar to the concept of entropy in thermodynamics and physics. So it's highly disordered water, it's low quality. Now, in terms of their freshwater consumption, they do not use a lot of fresh water in these evaporation ponds. They're literally just counting on the sun to evaporate as much of the water as possible to the atmosphere. In the process of doing so, they're crystallizing out sodium chloride and potassium chloride. So they're crystallizing out all of these salts. And herein lies the problem. In the process of crystallizing out those salts, they're losing lithium. Lithium is bound up in those salt crystals. Equally, they have to add some chemicals, lime, to deal with magnesium. And when they precipitate out the magnesium oxide, they're binding up lithium. So the downside of the evaporation ponds technically really is what you hit the nail on there, which is the yield. Their yield is about 40-50%. With DLE technology, one could increase that yield. You could put DLE on that geological brine resource and recover 85 to 90% of the lithium through a DLE system. And then in your downstream CRC, you could recover another 80 odd percent, depending on how you configure it. So you up your yield. It's not going to be as dramatic as some claim, but you will be able to up your yield with DLE in South America.
So is that the first output for DLE, or shall we really focus DLE on new ways to produce lithium? Because it sounds like a low-hanging fruit. You could be, if I'm very caricatural, you could be doubling your yield by marrying DLE with evaporation ponds. So why bother looking at other sources?
No, you're spot on. If DLE is successful, we will one day see it, at least I'm confident, we will one day see it upstream of evaporation ponds. They'll use DLE to produce a dilute, dirty lithium chloride, and then they'll use the evaporation pond to concentrate it. That is a much more elegant solution. However, the evaporation pond companies have been looking at DLE for 20 years. It's been around for a long period of time, and they haven't adopted it yet. And when you talk to them, I'm not sure what they've said to you, but when you talk to them, it's about the water consumption, because Generation 1 DLE does consume a lot of water, and to your point, they don't have water. And then also the capital cost. It hasn't been as capital cost competitive as building a big pond. Relatively economic to put ponds in deserts if you have the land, which they tend to have. In terms of DLE's first market application, I think that it's wisely focused on geological brines in North America and Europe, like the Standard Lithium's doing in the Smackover or Vulcan in Germany, and then soon there's apparently going to be some developments in France as well. So we do not have the technological option to put a pond there. And so I think you'll see DLE grow up there first, become successful, and then start to be installed on the evaporation ponds.
You shortly mentioned DLE Generation 1 and Generation 2. Can we define those two generations?
Generation 1 DLE, which has been around for over 20 years, it's an alumina-based absorbent. I think in France you call it aluminium.
Yep.
Our American friends call it aluminum. So it's an alumina-based absorbent. And the alumina-based absorbent, the lithium-containing water flows by it. So it's either a powder or a resin-like material. Flows by it, and that absorbent grabs the lithium. Okay, so that's fine and dandy, but now you need to release the lithium. The way you do that is you stop flowing the brine past the absorbent. You now flow water past the absorbent. It's a water elution. So alumina-based water elution. And it works, and you can very mildly concentrate the lithium, but more importantly, you reject a whole pile of total dissolved solid and salinity. You're essentially improving the lithium to TDS ratio. And that's a key metric we'll talk about more, lithium to TDS. That's Generation 1, been around for a while. And there's some great companies that have really tuned it and improved its efficiency. Generation 2 is a different fundamental technology. That's where you have a titanate or manganese oxide based absorbent. You again flow the lithium brine past it, and it grabs the lithium. And it does a better job at grabbing the lithium. But there's a catch. In order to elute the lithium from the absorbent, you need to wash it with acid. Thermodynamics again, kinetics. Generation 2 DLE plants are quote unquote hooked on drugs for many, many years, right? So they have to keep pumping acid into the system. When you pump acid into a system, you lower pH. That means you then have to add base to elevate pH again. Generation 2 has a very significant advantage in that it can concentrate lithium. It can achieve a higher lithium to TDS ratio. It's a capital cost smaller plant, but the operating costs are higher because you're constantly having to elute with acid and then adjust with base. Most DLE plants have a chlor-alkali plant bolted next to them in concept to produce the acid and base that will be continuously used.
You mentioned generation 1, generation 2. It's tempting for me to ask, is there a generation 3 in the pipeline?
There's a lot of people working on generation 3, university levels, national lab levels, some startup companies. We're watching it closely and it'll be exciting to see what comes out.
So that's something which I'd like to understand is why do you watch that closely? Because they are your neighbors, but it's not in your house. It's whatever happens before your CRC, but it's in the DLE field. You could say whatever they have at the outputs, we ensure that we can manage it. So why do you look into their garden?
We want the best for our clients. And now we only look into their garden if we're invited to do so. But a lot of people put a lot of information online. They publish academic papers. And at our heart, Saltworks Technologies, we are a technology firm and we're innovators and we're curious. So we're constantly on the lookout to find better technologies that will help our customers accomplish their goals, including if they're not invented here. We're very proud of our digitized modular plants that we build for our customers today. But customers do ask us, because of our position in practicing CRC and being downstream of so many DLE technologies, they do ask for our counsel on DLE systems, which way their compass should point. DLE is a bit of a smoky space. There's been some big claims made. There's been a few houses of cards built. And there'll be some winners in the future. There'll be some legitimate players, but there'll also be some that fall by the wayside. And so it's very confusing for asset owners to navigate that space if they don't have the technological background around the periodic table of elements in water and kinetics and et cetera. And that's what our people do here every day.
I remember that from our first conversation where you say you're basically moving the elements in the table of elements right and left. So you just inaugurated your lithium refining center. What is it that you can do?
So we have 2 test pilot plants. Pilot 1, 1 ton a day. It's over there. Pilot 10, 10 tons a day, and it's outside. Clients ship DLE eluent, and we convert it into battery-grade lithium carbonate or battery-grade lithium hydroxide.
10 tons a day of lithium carbonate.
Oh, I wish. 10 tons a day going in of dilute. Okay. So DLE produces, and the DLE folks might throw bricks at me for saying this, DLE produces dirty dilute lithium chloride. You still have to refine it. You still have to concentrate it, remove a whole ton of water, and then convert it.
And so what you try to find out here is what is the right technology to do that and to fine-tune that so that for their demo plants or their big plants, they go with the right technologies. So that's really what you're doing.
Exactly. We develop PFDs, process flow diagrams, optimize them on a mass balance level at a computer level, and then test it in our pilot plants to confirm the PFD, but also to, very importantly, provide them lithium carbonate samples and lithium hydroxide samples that they can then provide to their off-takers.
So that you can prove that it's really battery grade.
Correct. And they can take those samples to the off-takers, they can sign contracts, they can then secure financing and build their facility.
When you discuss with water professionals, they always tell you that every drop of water is different. Hence, especially when you go on the dirty side of water, you have to cater your process all the time. And when you discuss to financial people, they tell you, come on, can that really be true? Can't we just standardize stuff? Now that's a different field. It's concentrated brines, it's dirty lithium carbonate eluents. Is it really that way that every single sample you receive is different? Or do you also see trends like that comes from South America, it's going to be mostly like that? Or that comes from North America, it's going to be mostly like that?
There's absolutely trends, and there's a lot of similarities within lithium plants. I'd put it this way, and again, these examples behind us are a great example. Any CRC plant, it's often the same processes. You'll have a lithium carbonate reactor, and you'll have an evaporative crystallizer or an evaporator that's behind you. But the process flow diagram for that plant will differ based on their chemistry. You're rearranging the parts of Mr. Potato Head to put together an optimized plant.
So that means the step 3 could become step 2, or how much do you rearrange it? Okay.
Correct. There's a little bit of furniture rearrangement. Step 5 in some cases might be bigger. Step 5, for example, would be an ion exchange polish. Some brines have increased boron levels, so they might need a boron extraction system and increased ion exchange. Some plants or some lithium resources have lower boron, so they do not need that step.
And from all these steps, what's the tricky part?
DLE.
Okay, so really not within the CRC. The tricky part comes before.
Yeah. To your very good point, there have not been really legitimate end-to-end DLE commercial plants built. There is a DLE system operating in South America that's been operating for some time, Generation 1, and it's bolted to an evaporation pond. So we should have actually spoken about that. So that plant's been around for some time. And then there's also some DLE CRC plants in China.
So what's the best combination? Do you always bolt the CRC next to the DLE or the evaporation pond or whatever it is? Or would you also see the possibility to have this conversion plant somewhere else, like closer to the battery production?
Oh, good question. This is where one can get into distributed production. So let's take, for example, an oil field type analogy. And there's a lot of lithium containing oil field brines. And in the oil field, they'll often use the term a battery. I'm not talking about battery in terms of positive and negatives, but a gathering battery. And so you might, for example, have a series of wells that come to one DLE spoke, if you will. That DLE system is producing dirty dilute lithium chloride. You then may have some concentration close to the DLE, reverse osmosis, maybe ultra-high pressure reverse osmosis, and produce even more concentrated lithium chloride juice, which you then ship to a centralized refinery. That centralized refinery is receiving concentrated lithium chloride from various locations and then further refining it and converting it. So sort of like a hub and a spoke strategy. Some are looking at that strategy for their lithium developments. In terms of shipping lithium chloride right to a battery manufacturer, I've certainly heard talk of that, but you're shipping a lot of water. And those economics and the GHG impacts of it may be questionable.
Economics, as we speak, I mean, when we spoke last year, you mentioned how lithium had multiplied its price by 5, and that was the highest it had ever been at that time. And since then, it's been a bit up, a bit down, but mostly flat. All specialists say that it's going to be staying above 50,000 per ton. At that price, the beauty is that everything is profitable, everything is economical, including putting rocks, not even concentrated, into boats and crossing the world with it. So in that happy bubble, we could be testing everything. So is it like an open space for the imagination, or how would you see that?
In my view, I think a key metric there is going to be speed. So eventually high prices will solve high prices. A lot of projects will get developed and prices will erode. And so those who are first to production with speed will then achieve cash flow and achieve profitability and will survive. And of course, they hope that their costs are among the lowest on the cost curve. Those who are late and on the highest on the cost curve, they may miss the boat. It may be that at that time, on an inflation-adjusted basis, lithium comes back down to $10 a kilogram. So it's very important for speed. Hence, again, why these digitized, modularized plants are beneficial. You can get them out fast, you can get them installed, you can get to production.
There's this saying that in a gold rush, the one making money is the guy who sells the tools. So it's not a gold rush, it's a white oil rush, but we all know that at least 2 million tons will be needed by 2030. Others say 3 or 5. I mean, everybody's throwing numbers. One thing's for sure is that there's an imbalance between demand and supply. It's white oil, and you are basically selling the tools. So is that the best position to be in the market?
It depends on who you ask. It would be wonderful to own a lithium resource, but you're less diversified. You've got one chance to make that resource successful. Saltworks, our view is we're quite diversified in selling the equipment and the most advanced tools to help people refine and recover their lithium. There's a lot of lithium on this planet, and there's a lot of lithium in all the various brines. And the world could easily get to the 2 million tons per year of lithium carbonate that we require with the resources that are known today. It's going to be those that can move fast enough and develop the projects in a risk-managed fashion that will supply that market. That's, again, where we really focus, is providing those tools, providing them that they're robust, they're reliable, they're effective, and they're digitized, and they're fast.
So we've discussed a lot of objective parameters. I mean, the cost, the technology, and the market trends, which is maybe already a bit more subjective, but still pretty objective. There is nevertheless a big subjective part to all of that, which is geopolitics. You have an existing route for lithium, which starts in Australia, puts whatever they can put into boats, ship it to China. That route has been slowed down, which means China has started expanding to Africa. I mean, I'm not rewriting the full geopolitics. What I'm interested in is your view of this North America nexus. Just in Vancouver, I found 12 companies which are more or less dealing with lithium at different stages of the lithium route. Even when I was discussing with Canadian companies, they told me, maybe we shall make sure that we have a Canadian value chain from A to Z, because repeating what we've done with oil and the dependency to the US might be dangerous. So is it like every single country will need ultimately to build its lithium value chain? Or where do you set the bar?
Okay, all right. We're talking about geopolitics.
That's a broad one.
With a technical geek. So if we do talk about geopolitics in lithium, we should certainly talk about Bolivia at some point. Because Bolivia, if they developed their lithium natural resource and just put ponds in, they would come close to solving the supply-demand imbalance. Now, as far as geopolitics in the US and Canada, this is maybe just geology, and I won't pretend to be a geologist. The US has higher concentration lithium-containing brines. You take the Smackover or the Salton Sea, their lithium concentrations are 250, sometimes 300 milligrams per liter. So they're 250, 300. In Canada, we're 70, 100. The best was just found, 190 odd. So Canadian lithium brines are weaker in terms of lithium concentration. But like everything in Canada, they're enormous. Everything's bigger here. We're a huge natural resource country. So there's no doubt a technological leap that needs to be made in Canada to provide access to those lower concentration lithium brines. And there's good companies working on that. At the end of the day, I'm not sure that many automotive companies would really care where they got their lithium as long as they got it. I think their biggest need right now is supply. I'm sure they'd care if it was unethical, but if they could buy it from, if there's ethical production in South America, which there certainly is now, or Bolivia or Canada or the US, I'm not sure they would be too fussed about that.
That's another one where I've raised that question to many of the people I've met within that deep dive on the lithium topic, and I've got contrasted answers. So I'm interested in your opinion. You mentioned how they might look at what's ethical or not ethical. If in the coming decade we have such a strong imbalance between supply and demand, wouldn't they just grab whatever is available, regardless of ethics?
I honestly don't know the answer to that. And of course, the question of ethics is a sliding scale. You could have the greenest, most ethical lithium in the world. It'd probably be among the higher cost. I know I wouldn't want to buy an electric car that had unethical lithium, unethical critical minerals. It's that sliding scale. And where does white turn to gray to black? I think there'll be a lot of gray lithium on the market. And I think the automotive companies are going to accept it.
You mentioned the minerals, and probably the best or worst example is cobalt, where anyways 100% of the world's production is unethical. So
correct.
But that's a tangent. I don't want to bring you there.
Yeah.
I mentioned,
if you buy an EV, buy lithium iron phosphate battery.
So you can be choosing when you're taking your car, you're basically choosing the supply route. That's a good one.
Lithium iron phosphate's a more sustainable lithium resource.
Coming back to this Canadian story, I try to track all the projects which are announced to come live between now and 2030. I made a list of them. Maybe I missed one. So if anyone wants to correct me, I'm really up for corrections. But there's a strong pattern. 40% are developed by Australian companies, 40% are developed by Canadian company, and then the rest of the world is working on the 20% remaining projects. Does that make Canada the future big lithium country?
The Canadian companies that are developing lithium projects, they're often not on Canadian resources.
Absolutely.
Yeah.
But the company itself which develops it is.
Yep, correct. So Lithium Americas will soon hopefully build Thacker Pass, America's largest lithium mine. They're headquartered in Vancouver. Standard Lithium, who's a leader in DLE and lithium brine extraction on the Smackover Reservoir in Arkansas, is headquartered in Vancouver. There's a lot of mining talent in Canada, similar to Australia. And I think what you're seeing is you're seeing a natural progression of that into the lithium industry. But they go where the resources are.
Do you team up with your neighbors?
Yes. Absolutely. Neighbors meaning in Vancouver or neighbors meaning in the US?
In Vancouver would be the closest neighbors. Then there's another spot in Calgary, and then probably in the US.
Yeah, no, we do. We go where our clients are looking for our type of advanced technology and modular solutions. Back to the discussion around there being a lot of lithium and a lot of lithium developments underway, I think the industry is soon going to find that one of their constraints is process equipment supply.
What do you mean by that?
There's not a lot of companies producing the process equipment to direct lithium extract the lithium and then to concentrate and refine and convert it. They're going to find longer lead times.
So you're saying that basically you might be the bottleneck.
Correct. Us and our competitors. And that has implications on the water treatment industry as well, because with the lithium industry heating up and these clients move fast and they have a willingness to pay, that's going to draw capacity out of the water treatment industry. This will all unravel in the coming years. I hope I'm wrong, but I think, in fact, we already know that lead times are increasing across the board. Some of our competitors are quoting up to 3 years.
I won't give any names, but I can tell you a bit of behind the scenes. I've discussed with some water professionals, and I was surprised to see them moving into the lithium space. And I asked them why they did so. And they told me we are sick and tired of these 3 to 4% profit margin markets. We also want to go into the 30 and 40% profit margin market. So it sounds like your provision has lots of chances of happening. You mentioned some of your competitors are 3 to 4 years lead time. What's your lead time right now at Saltworks? Are you reaching limits? Can you grow as fast as the market?
It depends. For a end-to-end plant, multiple unit operations, our lead time's about 12 months. For a single unit operation, an extreme UF, it's about 6 months. For a bigger plant, it will increase, but lead times are absolutely increasing and across the board.
We're in the middle of an amazing production center. You have everywhere across the building additional tents with stuff happening. Is it that you're moving the walls, or do you have to grow faster?
Well, we do a lot of testing outside. And welcome to rainy Vancouver, so we have to keep the rain off of things. We won't grow out of this facility anytime soon, so we have work underway. We can 4x production at this facility, and we'll do that, but we'll soon be adding a satellite facility. Alongside our growth, all of our amazing partner vendors have been growing. So these steel frames are fabricated in British Columbia. These tanks are fabricated in Texas. Our electrical panels are made by a great company here in British Columbia. They've grown 40% alongside of us. So the whole industry is growing.
What's your growth rate? In terms of headcounts, let's use that one.
So our revenue and order book is growing much faster than our headcount because the company was designed to scale, and we're now seeing that. But our growth rate's about 100% a year, whereas our headcount's about 30-40% a year.
So that's the typical path of a unicorn.
Maybe, but we're not trying to achieve that status. Sincerely, honestly, like doing the good work to deliver robust, reliable technology that either treats harmful wastewaters to protect aquatic ecosystems or helps refine and recover lithium to advance the EV revolution, advance grid energy storage, and to do so in a more sustainable manner.
I mentioned my tracking of the projects. Out of these projects, there's a minority of DLE projects. I found 11 of them, which are in a phase where they are beyond the definitive feasibility study, or about to release the DFS. These 11 projects represent a $7.7 billion investment. Is that also on the critical path?
I could be biased. Permits are an absolute requirement. Lack of permits can derail things, or lack of stakeholder involvement. That could derail things completely. There's a lot of lithium in the world. There's a lot of capital that wants to be spent on lithium in the world, but there are not a lot of companies that can genuinely build and deliver full-scale plants, both at a DLE and at a CRC stage. What we've found, what I consider the companies are very forward-thinking, they're working early to develop partnerships with DLE companies, with companies like us, and with the manufacturing capacity to make sure they can deliver. If they wait too long, they might find that they're in a 3 or 4 year lead time window.
Let me give you my personal little project, because hearing you, I might have to move fast. So I like to secure that we have everything in the right direction. To give you a bit of background, I'm coming from the south of Alsace, which is the eastern part of France, which used to be a place where there was potash mining. The full underground is full of potash mining. And once they exhausted the potash, they had a very clever idea. They used those mines to store some dangerous waste. They did that for 3 years, and then it caught fire, and then the mine broke down. Then they had to stop. And now it's been 20 years that they're wondering what to do with that waste, with the mine, with whatever. That's one portion of the story. The portion of the story I won't be going into today. The other portion of the story is that as they were evaluating the impact on the environment of that potential hazard somewhere in the ground, they took some water samples and they found out that they had high lithium concentrations. And actually, I have to say, nobody mentioned it. It's just that I read the report, and the report was talking about everything else because they really looked at the environmental hazard. And when I looked at the report, I said, hey, sounds like a lot of lithium. It's kind of stupid what I'm doing because I'm doing that on record and people might be stealing that idea, but it sounds to me like I could become a billionaire with your help. So in preparation for our discussion, I sent you my analysis of water.
Yes.
And let me start with the lithium itself. Mm-hmm. I compared it to what I knew. So I compared it to Vulcan's project in Germany, and I compared it to the Salton Sea in the US. And my sample has almost twice the lithium. Is that good news?
On the surface, yes. But there's a metric in lithium that a lot of people don't speak about, and that's the lithium to TDS ratio.
When you say on the surface, yes, I would expect that my lithium to TDS ratio is very bad.
You're better than the Salton Sea. You're not as good as Vulcan.
What's in particular, I mean, it's really the TDS, so the total, which is problematic, or do you have specific scavengers that you should look for?
There's many dimensions to this. Your lithium resource, how much water is there? Is it just one underground mine that once you've extracted it, you're said and done, or is that replenished, and does the lithium continuously flow in?
I don't know if the lithium will be flowing. What I know is that it's part of the Rhine Valley water system, which is one of the biggest of the world. So water is plentiful. I don't know exactly where the lithium comes from. So the lithium source might be depleting at some point. I didn't raise money yet, so
Yeah, so let's take the optimistic view, and both of us can pretend to be geologists. Let's assume then that this lithium resource continuously gets recharged with water and dissolves more lithium and brings it to the well where you're bringing up lithium. So if that's true, then that's a good thing. You'll have a continuous flow of water from which you can continue to extract lithium. Your lithium, am I allowed to disclose to your listeners what your lithium concentration is?
you can.
All right, so thank you very much for this data. Your lithium concentration is very good. It's 300 to 430 milligrams per liter versus the Salton Sea in this data set being 200, sometimes a bit higher, and then Vulcan being 200. So you absolutely have higher lithium concentration. If you have the flow rate, that's a good thing. Do you know if you have a means to dispose the brine after you've extracted the lithium?
I guess I could put it back exactly where it was, which might not be solving the environmental hazard, but I'm here to make money, so I'm fine.
Yeah, so you need to find a place to put it, and find a place to put it that it doesn't frustrate or disrupt your lithium resource. You know, you've extracted lithium, you put the brine back underground, you might just be diluting your lithium resource. So brine disposal is absolutely key to DLE projects.
Okay.
And this needs to be a DLE project. Otherwise, you'll have all this water on the surface and nowhere to put it, and I presume you cannot build evaporation ponds in the south of France.
Okay, I could say that my hometown is Colmar, and just next to Colmar, we have the place which is the driest of the entire France. But it's right that compared to other countries, driest of France still doesn't mean much. So yeah, evaporation ponds probably are not a possibility,
Right.
especially because we wouldn't find the ground for that.
Yeah, stakeholders and permits. So I check into permitting, in particular around brine disposal, because if you can't dispose of the brine, your project's probably dead.
Okay.
So you need porosity, you need flow, you need brine disposal, you need infrastructure, power. But then if we get into the chemistry, Vulcan's lithium to TDS ratio for our resource is 0.002. Yours is 0.013, whereas the Salton Sea is 0.001. And your TDS is very, very high. So although you've got this 300 to 400 milligrams per liter lithium, your TDS is 240 to 360,000. So it's nearly saturated. And that's why you must use DLE. If you just try to evaporate the water off and precipitate out the salt to concentrate up the lithium, you lose all the lithium with the precipitated salt. So you need DLE. And then becomes a question of, do you go generation 1 DLE, alumina and water wash? Or do you go generation 2, titanate, manganese oxide, and acid and base? What's water access like in your region?
Plentiful. So
Okay.
really the Rhine River could stop flowing, we would still have water for a century. So water is available.
Okay. And if you want to do it fast, because you need to get to market fast, you'd probably want to go generation 1. DLE technology. It's readily and available today. If you can solve the brine disposal problem, then you might be onto something.
So you're saying that the Salton Sea, which is developed by Berkshire Hathaway, so Warren Buffett, which got 14 million grants from the federal US government at the same day the Biden administration was inaugurated, has less of a good project than I could have in my backyard.
I do not want to say anything about their project being lesser good. Everybody knows that the Salton Sea is a very complicated resource. So we've only talked about a few metrics. Then there's all of the other chemistry in the soup. Is there H2S in your water? And does that need to be managed? What happens when you depressurize your water? Are there naturally occurring radioactive materials, norms, in your water? And the Salton Sea, it's a very interesting resource, but it has a lot of stuff in it. And that's why it's fantastic that the DOE and companies like Berkshire Hathaway Energy, companies like ESM and others, Controlled Thermal Resources, are all working to solve that problem.
If I zoom out from my very particular case, which I know because I really tell now too much, but my father retired end of last year, and his only project he's still pursuing is getting those critical waste out of the ground. So it's like really now the goal of his life is to get that done. And he thought that maybe if I can find some use for that lithium, it could help. So long story short, what I'm wondering is that is this kind of lithium rich resources a bit everywhere and we just never looked for it?
There is lithium everywhere. I'm not sure that we've never looked for it. People have been aware, but now because of high lithium prices, people are becoming increasingly aware. Again, I come back to there are no shortage of lithium brines that can supply the world's needs. It's just a matter of permitting them and building the plants.
So assuming I get the permits right, assuming I order all the systems from a DLE company you're going to recommend me and then all the CRT from you, what would be your expectation in terms of timeline? When can I be up and running?
I'll set permits aside because I don't understand them. I mean, we'll assume you have brine disposal. You're probably looking, and if you and the money's available, you're probably looking at about 4 years. And you're probably looking about at a cost of production from a process equipment standpoint, coupled with chemicals and energy, about $10,000 a ton.
So with today's spot market of 70,000, I have a good potential to make a good profit.
Yeah, you still need to build a building, you need to do other things, but that's the process equipment, the core of it. DLE plus CRC, $10,000 a ton. Not what some people are saying on the stock market.
Okay, so that might be the last episode of this podcast, because right now I'm changing gears and I'm becoming a DLE play. But thanks a lot for having taken the time to study a bit my stupid little project.
It's not stupid, it's fascinating, and it's great that you're out there innovating and hunting. You may be onto something. You may not want to publish this podcast.
No, I sure want to publish it. I have one more question on that market, which is, I joked a bit about Warren Buffett being involved in the Salton Sea. Bill Gates is involved with LILAC. Mm-hmm. Is there like a move from the 80s and 90s big guys, big innovators, or big financial persons to now be looking specifically at that lithium topic?
I don't know. I honestly don't know. It's great that Bill Gates is out there spending some of his money on technology through breakthrough energy ventures. Others are too, right? So LILAC is a good DLE company. There's another one, Summit Nanotech, based in Calgary. They're both Generation 2 DLE companies, both working very hard. Then you have the Generation 1 DLE companies, and they're all receiving a lot of funding, and for a good reason.
Who would be the Generation 1 lithium companies?
There's ESM. I need to be very careful here because some of them are our clients. Maybe people should Google.
Okay.
Yeah.
Sorry, I don't want to put you in a bad position.
Me. Yeah, but a shout out to all of the lithium innovators out there trying to improve lithium extraction technology, to improve its sustainability and improve the cost curve. There's a lot of hardworking people.
And if you can round it off with a bit of a joking touch, we all know that Elon Musk spent a hell of money on Twitter, knowing that Tesla might be in trouble anytime with lithium supply. Let's imagine you are the richest guy on earth and not Elon. Would you invest in Twitter or in a lithium supply chain?
I certainly don't want to comment on Elon or Tesla because I have great admiration
I guess,
for them.
That's
Yes, but I would absolutely be investing in accelerating lithium resource development and technology development. And I think you're going to see the Canadian government do exactly that in the coming future with their critical mineral strategy, just as the US government has.
That's one thing maybe on the geopolitical side, to come back a bit to that aspect of the story. The governments are pushing at different places. If you look right now what's happening in Europe, there's a big push for battery plants, so gigafactories. And there's a 10-to-1 ratio worldwide between what's invested in gigafactories and what's invested in lithium.
Spot on.
Is it because that's really the cost ratio, that a gigafactory costs 10 times more than the lithium supply chain? Or is it because we are not really focusing on the right part of the supply chain?
You've uncovered an imbalance that everybody who works deeply in the lithium sector is aware of. There's not going to be enough lithium carbonate, lithium hydroxide to go into all of the lithium battery factories being built. It takes 2 years to build a lithium battery factory and a couple $1 billion. It takes a lot longer to build a mine.
So it looks like my project has a good a good position in that market, because thanks to you I can be up and running in 4 years, and the imbalance is here to stay. So
it does. Yeah, if there's brine disposal there and if there's good porosity, it's very exciting. Maybe I'll quit my job and join you.
Then I'll get you to Europe for that. Very good. So is there an elephant in the room I missed in that word of lithium?
I think you've peeled back all of the layers, and it's wonderful that you're helping your listeners and your viewers stay informed and bringing different parties in.
Well, thanks a lot for having taken once again the time to chat with me, Ben. I have some rapid fire questions to close.
It's time for the rapid fire questions.
We are recording that just 1 month away from the UN Water Conference, so I'm opening with that rapid fire question. If you had one topic that you could put on the agenda of the UN, what would it be?
Stop putting deleterious matter into the rivers and lakes that provide healthy, long-term, sustainable drinking water. Protect the rivers and lakes, you end up protecting drinking water for millennia.
The problem is that you got my traditional list, so I have to be creative. What's your favorite movie?
Right now, Totoro.
Don't know it.
I have a 3-year-old child, and she loves Totoro. It's a Japanese movie about a wonderful mythical being that takes care of children and helps them find their mother.
I have to discover it because we are more a Peppa Pig family, but
Muddy puddles.
Did I miss one of the aspects of this lithium value chain, and who would you advise me to to speak to next?
I think it'd be very interesting to speak to some of the battery recyclers, Li-Cycle
Li-Cycle.
or Redwood. They're equally building lithium concentration, refining, and converting plants, but from waste feedstock.
Ben, it's been a pleasure to spend that hour with you. I will put your links into the show notes, of course, but if there's anywhere else that I should redirect people outside of your LinkedIn and Saltworks website, what would it be?
I have a very small online footprint, so that's exactly it. But Saltworks is definitely open for business and looking to help accelerate the EV revolution with sustainable lithium.
Which kind of leads or customers would be the right fit? The ones which you wouldn't know yet?
No more, please.
No more. Okay.
Yeah, the cup is overflowing. We're just really deeply focused on delivering for the key lithium projects.
Amazing.
Thank you for having me on your podcast. And
Thanks.
Thank you for helping to inform your listeners.
And let's discuss next year.
Wonderful.
Thanks for listening to Don't Waste Water. This podcast was brought to you by GF Piping Systems. Loved this episode? Head over to Apple Podcasts to subscribe, rate, and leave a review. See you next time.